welcome back to AMG Cloud. In this video, we are going to discuss 5 questions of the AWS Solutions Architect Associate exam. Please make sure to like this video before we begin. So let us begin with our first question. You have an in-memory database launched on an EC2 instance and you would like to be able to stop and start the EC2 instance without losing the in-memory state of your database. What do you recommend? So you have 4 options over here. This is your option 1, this is your option 2, this is your option 3, and this is your option 4. And let me tell you, you have 10 seconds timer. That means you have 10 seconds to answer this question. So your time starts now. Time up. Now let us analyze the answers and gradually we'll find the correct answer. Okay, so let us start with option 1. Use an EC2 instance stored. This option is incorrect. Why? Because it is a temporary storage that's deleted when the instance is stopped. Right? So option number 1 is the wrong answer. Let us go to option number 2. Mount an in-memory EBS volume. This option is incorrect because EBS volumes are disk based, not in memory. Okay, so this is also the wrong option. Let us go to option number 3. Create an AMI from the instance. This option is also incorrect. Why? Because it creates a snapshot of the instance but doesn't preserve the in-memory state. Right? So this is also the wrong answer. Option number 3. Lastly, option number 4. Use EC2 instance hibernate. This option is correct. Why? Because it saves the instance's state, including the in-memory database, to the root volume when stopped and restores it when it is started. Okay. So this is why option number 4 is the correct answer for this question. Got it? Let us move to our next question. An IT company runs a high-performance computing HPC workload on AWS. The workload requires high network throughput and low latency network performance along with tightly coupled node-to-node communications. The EC2 instances are properly sized for compute and storage capacity and are launched using default options. Which of the following solutions can be used to improve the performance of the workload? Again, you have 4 options. This is your option 1, this is your option 2, this is your option 3, and this is your option 4. Okay, you will again have 10 seconds timer. Your time starts now. Time up. Now let us analyze the answers. We'll start with option 1. Select the appropriate capacity reservation while launching EC2 instances. This option is incorrect. Why? Because it ensures instance availability, not performance. Right? So this is the wrong answer. Option number 1. Select dedicated instance tenancy while launching EC2 instances. Option number 2. This option is incorrect. Why? Because it provides isolation, not performance boost. Okay, so your option number 2 is the wrong answer. Okay, let us go to option number 4. Select an elastic inference accelerator while launching EC2 instances. This option is incorrect. Why? Because it's for machine learning workloads, not HPC. Okay, so this is the wrong answer. Option number 4. Let us go to option number 3. Select a cluster placement group while launching EC2 instances. This option is correct. Why? Because it enables low latency, high throughput networking and node-to-node communication, ideal for HPC workloads. Okay, so at the end, your option number 3 is the correct answer. Got it? Let us go to the next question. A financial services company recently launched an initiative to improve the security of its AWS resources, and it had enabled AWS Shield Advanced across multiple AWS accounts owned by the company. Upon analysis, the company has found that the costs incurred are much higher than expected. Which of the following would you attribute as the underlying reason for the unexpectedly high costs for the AWS Shield Advanced service? So you again have 4 options for this question. This is your option 1, This is your option 2. This is your option 3. And little bit scroll down, and this is your option 4. Okay, so these are the 4 options that you have. Got it? You'll again have 10 seconds timer, and as it is a little bit difficult to navigate, you can take some more time other than 10 seconds. If you want, you can pause the video. Okay, but I'll provide you 10 seconds itself. Your time starts now. Time up. Now let us analyze the answers. This is your option 1. Savings plan has not been enabled for the AWS Shield Advanced service across all the AWS accounts. This option is incorrect because savings plans are not directly related to AWS Shield Advanced costs. Right? Wrong answer. Option 1 is the wrong answer. Okay. Let us go to option number 2. AWS Shield Advanced also covers AWS Shield Standard plan, thereby resulting in increased costs. This option is incorrect because AWS Shield Advanced is an upgrade to AWS Shield Standard, not a duplicate charge. Right? So option number 2 is also the wrong answer. Let us go to option number 4. AWS Shield Advanced is being used for custom servers that are not part of AWS Cloud, thereby resulting in increased costs. This option is incorrect because AWS Shield Advanced only protects AWS resources, not custom servers outside of AWS. Okay, so option number 4 is also the wrong answer. Option number 3, let us see. Consolidated billing has not been enabled. All the AWS accounts should fall under a single consolidated billing for the monthly fee to be charged only once. Okay, this option is correct because AWS Shield Advanced charges a monthly fee per account. Without consolidated billing, each account is charged separately, increasing costs. Okay, so at the end, your option number 3 is the correct answer. Got it? Now let us move to our next question. An application runs on EC2 instances in a private subnet behind an application load balancer in a public subnet. The application is highly available and distributed across multiple AZs. The EC2 instances must make API calls to an internet-based service. How can the solutions architect enable highly available internet connectivity? So you again have 4 options for this question. Let us see the options. This is your option 1. Okay. This is your option 2. This is your option 3. And lastly, this is your option 4. Got it? Now again, it is a little bit difficult to navigate. So you might need more than 10 seconds to answer this question. In that case, pause the video because I'll be providing you 10 seconds itself as it is the standard timer. And with that note, let us begin answering the question. Your time starts now. Time up. Now let us analyze the answers. First option, configure an internet gateway. Add a route to the gateway to each private subnet route table. This option is wrong. Why? Internet gateways provide internet access, but they can't be used directly by instances in private subnets. Internet gateways are used by instances in public subnets. Okay, this is why option number 1 is the wrong answer. Let us go to option number 2. Create an entity instance in the private subnet of each availability zone. Update the route tables for each private subnet to direct internet bound traffic to the entity instance. This is also wrong. Why? Entity instances are a good option, but they should be placed in a public subnet, not a private subnet. Also, managing multiple entity instances across availability zones can be complex. Alright, this is why option number 2 is the wrong answer. Let us go to option number 4 now. Create a entity gateway and attach it to the VPC. Add a route to the gateway to each private subnet route table. This is also wrong. Why? While NAT gateways are the right choice, you can't attach an NAT gateway directly to the VPC. Instead, you create a NAT gateway in the public subnet and update the route tables for each private subnet. Okay? So this is why this option number 4 is also the wrong answer. Let us go to option number 3 now. Create a NAT gateway in the public subnet of each availability zone. Update the route tables for each private subnet to direct internet bound traffic to the NAT gateway. Okay, so this option is correct. Why? Because NAT gateways are managed by AWS, highly available and scalable. Placing them in public subnets allows instances in private subnets to access the internet via the NAT gateway. Okay, so at the end, this is why option number 3 is the correct answer. You can see all the others are wrong. Yes. So let us go to our next question. Hope you understood this one. And this is the last question of this video. A manufacturing company receives unreliable service from its data center provider because the company is located in an area prone to natural disasters. The company is not ready to fully migrate to AWS cloud, but it wants a failover environment on AWS in case the on-premises data center fails. The company runs web servers that connect to external vendors. The data available on AWS and on-premises must be uniform. Which of the following solutions would have the least amount of downtime? So again, your 4 options for this question. This is your option 1. This is your option 2. This is your option 3, and this is your option 4. Okay, so I want you to see the options properly once more. These are the first 2 options, 1 and 2. These are the last 2 options, 3 and 4. Okay, so these options are again, they're huge and also difficult to navigate. If you want some more time, in that case you can pause the video and take your time. Okay, because I'll be providing you again 10 seconds itself. Let us begin the timer. Your timer starts now. Time up. Now let us analyze the answers. This is your option 1. Set up a Route 53 failover record. Set up an AWS direct connect connection between a VPC and the data center. Run application servers on EC2 in an auto-scaling group. Run an AWS Lambda function to execute an AWS CloudFormation template to create an application load balancer. So this option is incorrect because it uses a Lambda function to create an application load balancer, which takes longer than auto scaling. Okay, so this option number 1 is incorrect. Let us go to option number 3. Set up a Route 53 failover record. Execute an AWS CloudFormation template from a script to provision EC2 instances behind an application load balancer. Set up AWS storage gateway with stored volumes to back up data to S3. This option is incorrect because it uses a script to provision instances, which is slower than autoscaling. Okay, so your option number 3. Yes, your option number 3 is the wrong answer. Let us go to option number 4. Set up a Route 53 failover record. Run an AWS Lambda function to execute an AWS CloudFormation template to launch 2 EC2 instances. Set up AWS storage gateway with stored volumes to back up data to S3. Set up an AWS direct connect connection between a VPC and the data center. Okay. Big option. So this option is incorrect because it launches 2 instances, which may not be enough to handle the workload, and uses Lambda, which takes longer. Okay, got it? This is why option number 4 is the wrong answer. Okay, you can see option number 4 is the wrong answer. Now what is left? Option number 2. Set up a root 53 failover record. Run application servers on EC2 instances behind an application load balancer in an auto-scaling group. Set up AWS storage gateway with stored volumes to back up data to S3. This option is correct because it uses auto-scaling, which quickly launches new instances if the primary data center fails, minimizing downtime. Okay, so you can see option 1, 3 and 4 are wrong. Option number 2 is the correct answer. Got it? Okay, so that's how we come to the end of today's video. Congratulations for answering 5 questions successfully today. Please let me know your score down below in the comments. I'll be really excited to know that. Also, we have multiple questions, multiple sessions like these in our channel for AWS Cloud Practitioner as well. Okay, so you can go visit that playlist where AWS Cloud Practitioner questions are given. Also, if you want more for AWS Solutions Architect, please let us know, and you will also find a playlist for that itself. Okay, so you have Cloud Practitioner and Solutions Architect. You can visit the playlists and get as many questions as you want from there. Okay, so that's it for today's video. I look forward to you in the next session. Till then, keep learning, keep practicing and keep exploring. Thank you and bye bye.